Welcome to Pacific States University's online lecture series for BBA 302 Economics for Business. Today, we're diving into the economic model of demand, supply, and equilibrium. Now, you might have caught yourself wondering at the grocery store, why on earth does an organic Fuji apple cost $2.75 a pound, while the exact same looking conventional apple right next to it costs only $1.72? Or maybe you've noticed how the average price of gasoline always seems to drop steeply in the winter compared to the crazy highs of summer. Well, these aren't just random everyday mysteries. They are perfectly mathematically explained by what is arguably the most powerful tool in all of economics, the model of demand and supply. In our session today, we are going to exhaustively explore how these two massive, invisible forces interact to determine the prices and the quantities of literally everything you buy, sell, or consume. It's like unlocking the source code of the entire economy, so let's get into it. Here is our roadmap for today's lecture. First, we will cover the foundations of demand and supply. Second, finding market equilibrium. Third, shifting the curves. Fourth, we'll introduce the four-step process. And finally, we will wrap up with price controls and inefficiency.
All right, starting with Section 1, Foundations of Demand and Supply.
Okay, so economists are incredibly, absolutely precise with the word demand. In everyday conversation, you might say you demand a new sports car. But in economics, demand is not just wanting something. It represents a combination of two things: the willingness to buy and the actual financial ability to purchase that good or service. If you desperately want a brand new Porsche but your bank account is empty, you have zero effective demand in the market. Conversely, if you have $1 million but you hate driving, you also have zero effective demand for that car. You have to have both. Furthermore, this brings us to a fundamental rule, the law of demand. This law dictates a strict inverse relationship. As the price of a good rises, the quantity demanded of that good will almost always fall. And obviously, a fall in price will increase the quantity demanded. Think about gas prices, right? When they spike up to $5 or $6 a gallon, what happens? People naturally start combining their errands, they carpool, maybe they cancel that cross-country road trip. And a super crucial distinction I want you to burn into your memory right now is the difference between demand and quantity demanded. They sound the same, but they are totally different. Demand refers to the entire relationship across a whole range of possible prices. Quantity demanded, on the other hand, refers to one specific amount at one exact price point.
Let's crunch some numbers on gasoline to really see this in action. Observe how a price drop systematically impacts human behavior. At $2.20 per gallon, the quantity demanded across the market is 420 million gallons. People are being a bit conservative with their driving. But if the price were to suddenly drop all the way down to $1 per gallon, the quantity demanded completely surges to 800 million gallons. Everyone is taking road trips. If we were to map this out on a standard graph, with price on the vertical y-axis and quantity on the horizontal x-axis, we would draw a line sloping downward from left to right. That downward slope, that is the literal visual representation of the law of demand. As price goes down, the quantity stretches further out to the right.
Now let's flip the script and look at the other side of the transaction, supply. Supply refers to the amount of some good or service that a producer is willing to produce and actually bring to the market at each given price. While you and I as consumers are driven by utility and what we can afford, producers are fundamentally driven by one thing, the profit motive. Because of this, the law of supply states that there is a positive relationship between price and quantity supplied. Higher prices naturally and very powerfully encourage producers to supply larger quantities. Lower prices decrease the quantity supplied. When gas prices rise, oil companies are heavily incentivized to spend money expanding exploration, investing in entirely new pipelines, and paying overtime to keep gas stations open longer hours. They want to capture that profit. And just like we discussed with demand, we absolutely must differentiate supply, which is the whole relationship across all prices, from quantity supplied, which is just one single specific amount at one specific price tag.
Let's look at the producer side of the gasoline market to put the law of supply into perspective. At a rock-bottom price of $1 per gallon, producers are only willing to supply 500 million gallons. Why? Because the profit margins are just too incredibly thin to justify running their refineries at maximum capacity. It's not worth the wear and tear. However, as the price of gasoline rises up to $2.20, oil companies suddenly see massive dollar signs. They are heavily incentivized to ramp up all their operations, providing a much higher quantity of 720 million gallons. Graphically speaking, this means a supply curve slopes upward from left to right. Higher price on the vertical axis equals higher quantity on the horizontal axis.
Moving right along to Section 2, Finding Market Equilibrium.
This is where the magic happens. We've established the independent laws of demand and supply, but the true analytical power of economics comes from visualizing where these two forces finally intersect. When we have that downward-sloping demand curve and the upward-sloping supply curve interacting in the exact same market, they are going to cross at one specific point. This intersection is what we call equilibrium. And the word equilibrium, it literally means balance. It is the single price point where the plans of consumers and the plans of producers perfectly, seamlessly agree. At this exact point, the quantity demanded is exactly equal to the quantity supplied. If we refer back to our gasoline numbers, at a price of exactly $1.40, consumers demand 600 million gallons, and producers are willing to supply exactly 600 million gallons. There is absolutely no economic pressure causing the price or the quantity to fluctuate. The market has found its natural resting place, it's completely cleared out, nothing left over, nobody left wanting.
But let's be real, markets aren't always perfectly in balance right away. What happens when they're out of whack? Imagine the price of gas is somehow set at $1.80, way above equilibrium. At this really high price, producers are thrilled. They pump out 680 million gallons. But consumers? They balk at the price and only demand 500 million. This creates an excess supply, which we call a surplus. Gas is literally accumulating in tanks and pipelines with nowhere to go. To clear out this massive inventory and generate some much-needed cash, producers have an overwhelming incentive to cut their prices, putting downward pressure on the market until the price falls back toward equilibrium. Conversely, what if the price is way below equilibrium? Let's say $1.20. It's a bargain. Consumers rush out and demand 700 million gallons, but producers look at that low price and only supply 550 million. This creates excess demand, or a shortage. Gas stations run completely dry, massive lines form down the block, and sellers very quickly realize, hey, we can raise our prices and people will still buy. This creates upward pressure, pushing the price all the way back up to equilibrium. The market, remarkably, automatically self-corrects.
Section 3. Shifting the curves.
Up to this point, we've only been talking about price changing. But what happens when variables other than the price of the product change? Well, the entire curve moves. Before we look at those specific variables, we need to understand a core, absolutely fundamental assumption used in all economic modeling, ceteris paribus. This is a Latin phrase meaning other things being equal, or holding all else constant. When we build a demand or supply model, we are looking at the relationship between price and quantity under the strict assumption that absolutely no other economically relevant factors are changing in the background. To accurately isolate the real impact of a specific event, like, say, a sudden drop in middle-class income or the invention of a crazy new technology, economists rely on ceteris paribus. We freeze everything else in place, we examine one specific market change at a time, see what it does, and only then do we start combining the results with other factors. It's like running a controlled experiment in a science lab, but for the real world.
So what actually shifts demand? These 5 factors will change the quantity demanded at every single price level, picking up the entire curve and shifting it left or right. First, changing tastes and preferences. For example, from 1980 to 2021, U.S. per-person chicken consumption literally doubled. That massive dietary shift moved the entire chicken demand curve to the right and pushed beef to the left. Second, demographics matter hugely. An aging population heavily increases the demand for healthcare, walkers, and nursing homes. Third is income, which we'll dive into next. Fourth, the prices of related goods are massive drivers. We have substitute goods, like when iPads started replacing traditional laptops, shifting laptop demand to the left. And we have complement goods, things used together. Think golf clubs and golf balls. If the price of clubs skyrockets, the demand for balls will shift left simply because people are out there golfing less. And finally, consumer expectations. If you expect prices to rise in the future, say you hear on the news a hurricane is hitting tomorrow, you aren't going to wait. You will demand more bottled water today, shifting current demand sharply to the right.
Now, I want to zero in on income for a second, because changes in consumer income shift demand in entirely different directions depending on the exact nature of the product you're looking at. For the vast majority of things we buy, which we categorize as normal goods, rising income naturally means rising demand. When you graduate, get a great job, and start making more money, your demand for new luxury cars, nice vacations, and expensive brand-name groceries shifts to the right. You want more of them. However, there are fascinating exceptions, known as inferior goods. For an inferior good, your demand actually falls when your income rises. Think of really beat-up used cars, generic store-brand cereal, or cheap instant ramen noodles. As consumers grow wealthier, they completely abandon these products in favor of higher-quality alternatives. So a booming economy with rising wages actually shifts the demand curve for those inferior goods to the left.
Switching gears back to the suppliers. Supply shifts are entirely different. They are primarily driven by one thing: the underlying cost of production. If input prices fall, say there's suddenly an abundance of cheap steel available for auto manufacturers, their costs drop, their profit margins expand, and the entire supply curve shifts right. Weather is obviously critical, especially for agriculture. A massive multi-year drought in the Midwest will devastate crops and shift the supply of wheat heavily to the left. New technologies can radically lower costs. Think about how automation and robotics shifted the supply of manufactured electronics way to the right over the last few decades. Finally, government actions play a massive role. Higher business taxes or strict new regulations increase costs, shifting supply left. Government subsidies, which are basically free money to producers, shift supply right. But remember this one absolutely critical, unbreakable rule: a change in the price of the good itself never, ever shifts the curve. It only causes a movement along the curve you already have.
Section 4. The four-step process.
Okay, this is absolutely crucial. If you take away one practical skill from today's lecture, let it be this. This four-step process is your master key for solving literally any real-world economic event. Step 1 requires you to establish the initial state. You build your baseline by visualizing the original downward demand, upward supply, and noting that original equilibrium point. Step 2 asks you to play detective and pinpoint exactly which curve is impacted. Does the news event alter consumer willingness to buy, or does it mess with producer costs? Step 3 is determining the direction. Does the curve shift right for an increase or left for a decrease? Finally, step 4 is evaluating the grand outcome by comparing the old equilibrium to the new one. Let's do a practice run. Consider a year of fantastic, perfect weather for California salmon fishing. Step 1, we have our original salmon market. Step 2, weather directly affects production, not whether people suddenly like eating fish more, so this is undeniably a supply issue. Step 3, amazing weather increases the total harvest, shifting the entire supply curve to the right. Step 4, when we look at where the old demand curve meets this new supply curve, we find a much higher equilibrium quantity of salmon available to consumers, and because of that abundance, it's selling at a significantly lower equilibrium price. Boom! You just analyzed a market.
This whole dynamic brings to mind a brilliant point made by the incredibly influential economist Alfred Marshall way back in 1890. People back then, and honestly even today, often try to argue, is it supply or is it demand that really determines the final price of a product? Which one is the boss? Marshall argued that asking that question is exactly like asking which blade of a pair of scissors cuts a piece of paper. Is it the top blade or the bottom blade? The answer, of course, is that it's a ridiculous question. Both blades are actively involved, and neither can do the job alone. It is the continuous, incredibly dynamic interaction of both supply and demand together that dictates every single market outcome. You need both to make the cut.
Finally, Section 5, price controls and inefficiency. Now, everything we've talked about so far assumes a totally free market, but sometimes governments look at a market and say, no, we don't like that equilibrium price. They enact price controls to manage public discontent over prices that are perceived as either way too high for consumers or way too low to keep producers in business. A price ceiling is a legal maximum price, almost always designed to keep essentials affordable. Rent control is the classic example. But here's the catch. By legally capping rent below the natural equilibrium, tenant demand completely spikes, while landlords pull back and supply far fewer units. The inevitable result? Severe housing shortages and a massive deterioration in the quality of the apartments, because landlords have zero incentive to fix anything. Conversely, a price floor is a legal minimum, usually designed to support producer incomes. Think of the European Union, which spends billions guaranteeing high minimum prices for their wheat farmers. Because this price floor sits artificially high above equilibrium, farmers produce absolutely massive amounts of wheat. But at that high price, buyers don't want it all. This creates a gigantic rotting surplus, which the government then has to step in and buy up using billions in taxpayer money.
To really grasp why economists get so universally concerned about price controls, we have to talk about market efficiency and surplus. Consumer surplus is a fantastic concept. It's the gap between what you were willing to pay for something and the market price you actually paid. If you were willing to pay $50 for a concert ticket but got it for $30, you just experienced $20 of consumer surplus. You're happy. Producer surplus is the exact opposite. The gap between the rock-bottom minimum price a producer would have accepted and the higher market price they actually got. When a free market reaches that perfect equilibrium we talked about earlier, it maximizes social surplus, which is just the total sum of all consumer and producer benefits combined. It is perfectly efficient. Every trade that should happen does happen. However, when a government enacts price controls, they artificially block mutually beneficial transactions from taking place. This outright destruction of economic efficiency, the shrinking of the total social surplus, is called a deadweight loss. It is essentially money and value literally thrown away into a black hole. It benefits absolutely no one. So while price ceilings or floors might successfully transfer some surplus to a very specific politically targeted group, like a handful of current renters or heavily subsidized farmers, they strictly do so at the enormous cost of creating persistent shortages, massive surpluses, and a permanent deadweight loss for the broader society. It's a massive trade-off.
All right, that wraps up the core theory for today. Now it's your turn to do some heavy lifting. I'm leaving you with this mandatory discussion question, which you will need to complete in today's module on the class forum. Based on our 4-step process and our detailed analysis of market interventions, I want you to think about this scenario. If the government mandates a strict price ceiling on organic foods, with the goal of theoretically making them affordable for absolutely everyone, how will this specific policy impact both the quantity of organic foods supplied by farmers and the overall quality of those organics over time? I want you to apply the supply and demand models carefully, walk through the logic step by step, and deeply consider the concept of deadweight loss in your answer. Thank you all for your attention today. Keep studying those graphs, and I very much look forward to reading your analyses on the forum.